Hi to all, welcome to Softech Education. In this today video lecture, we will see some of the solutions of Apset 2019 Computer Science question paper. See the question number 21. In how many different ways can the letters of the word corporation be arranged so that the vowels always come together? Okay, so we have to find out that in how many ways we can arrange the vowels so that they can become together by using the string corporation. Okay, so in this corporation of strings we have a set of vowels and we have a set of consonants are there. So in the string, what are the vowels? The vowels are this O and this O and A and I and O. So there are 5 vowels are there, so that here I am writing that vowels. What are the vowels here? The vowels are O, A, I, O are the vowels, and the remaining are consonants, so they are called as C, R, P, R, T, N are the consonants in the string of corporation. So if you observe that this is entire, I am considering this entire string of vowels as a one character, and here we have 6 characters. They are totally the 7 characters. In the 7 characters, we observe that the R is repeated 2 times. Here the R and here the R is that, so that you can write it as 7 factorials by the 2 factorials into, and in this vowel of the O is repeated 3 times, so that you can write it as 5 factorial by 3 factorial, and after you performing the multiplications, then you can get the result, that is 50,400. So that the answer for this question is option number D, 50,400. And see the next question, the question number 22. What are the number of vertices in an undirected connected graph with 27 edges, 6 vertices of degree 2, 3 vertices of degree 4, and the remaining of degree 3? And we have to find out that what are the number of vertices in this graph which contains 27 edges. In addition of this, the question contains the information about the vertices, that is 6 vertices with the degree 2 and 3 vertices of degree 4 and the remaining of degree 3, so that we have find out that what are the number of vertices in this graph. And he has given information about that it contains the 6 vertices corresponding with the degree 2 plus and 3 vertices of degree 4 plus the remaining vertices, means that assume the remaining vertices are x, so which degree have the 3, and it is equivalent to the, what are the edges here? The edges are 27. But according to the handshaking lemma theorem, we can say that the degree of all the vertices is equivalent to the twice the number of edges, so that you can write it as 2 into E. E stands for edges, so that 2 into the 27, and finally we can write it as 6 into 2, 12, 3 into 4, 12, and 3 into x, 3x is equivalent to 2 into 27 is equivalent to the 54. Now it can write it as 24 plus 3x is equivalent to the 54, and 3x equal to 54 minus 24, and 3x equal to 30, and x equal to 10. It means that here the remaining vertices are 10 vertices. Now what are the total number of vertices here? He has given that 6 vertices plus 3 vertices and the x equal 10, the remaining vertices are 10, so that it is equivalent to the 19 vertices. So that the answer for this question is option number D, 19 vertices. And see the next question, the question number 23. Activities G, P and R are the immediate predecessors for activity W if the earliest finish time for the 3 are 12, 15 and 10, then the earliest start time for W is. Here we have to find out that what is the earliest time for the activity W. He has given that the W has the 3 predecessors. It means that the activity of W would be start only after the completion of G, P and R activities, that is G activity and then P activity and then R activity, and each and every activity have its the earliest time and the finish time, as well as here the P is also have its earliest time and the finish time, and here also it have the earliest time and the finish time, and W is also have the earliest time and the finish time. Here the earliest time for the G is not be given, so that we can assume the earliest time for the G is 0 and the completion time is given, that is the 12. So that here we can write here the 12. And for the P, the earliest time is not be given, so that we can assume that it was 0 and the 15 is the finish time, so that we can write the 15 here. And here for the R, the 0 is the earliest time and R is completed with the time 10, so that we can write it here that 10. And what is the earliest time for this W? That is the activity of W would be start only the completion of these 3 activities. So among these 3 activities, which one have a maximal amount of time which can take to complete its activity? The 12, 15, 10, among these 3 one, the 15 is a maximal value, so that here the W activities would be start at the 15. So that the answer for this time is, that is earliest start time for the W is the 15. Next, question number 27. Given the following grammars, he has given the 2 types of grammars. One is a G1 grammar and next one is a G2 grammar, and we have to find out that which grammar is an ambiguous grammar. That is, either a G1 grammar is ambiguous or the G2 grammar is an ambiguous, or both are the ambiguous or unambiguous. Okay, so for this one I can follow the positive mechanism. That is, I draw the positives for each and every grammar, and I can determine that which grammar is ambiguous and which grammar is unambiguous. Okay, first to take that G1 grammar, and before taking the grammar we have to consider that string. Here I am considering the string, that is W equal to that is A, B for the G1 grammar, and I try to get this string from the G1 grammar. That is, S is a start symbol here, and I am taking the first productional, that is S tends AB, S tends AB, that is S tends AB, and then A tends, that is according to productional, A tends A, and after that this A is to be derived by using the same productional again A, and finally A tends epsilon, and this B is to be expand by using the productional B, and finally this B is to be expand with the epsilon, so that the string is derived here A and then B, so that I got the string, that is W equal to A, B. And the same string I want to solve by using another another positives. That is, first I am taking that this second production, that is S tends A, B, S tends A, B, and this B is to be expand with the productional B tends B, and finally this B is to be expand with the epsilon, so that I get the string W equal to A, B. So after that, here from the string, from this positive also I got this W equal to A, B, and from this positive also I got the W equal to A, B. It means that for deriving the same string I got the 2 positives. These 2 positives are not equivalent, so that this grammar G1 is a ambiguous grammar. It is an ambiguous grammar. Next, to take the G2 grammar. The G2 grammar contains S tends A, S tends B, A tends A, B, A tends AB, B tends ABB, and B tends epsilon. And for this grammar I am taking that production rule, that is called as W equal to AB. So I am expanding this one by using the positives mechanism. That is, first I taken that S tends A, and then this A is to be expand by using the third production rule, that is A tends AB, so that I got the string W equal to AB. Okay, so now I am expanding, I am drawing the one more positive by using the same grammar G2, that is by taking the different production rules. That is, I am taking here the S tends B, and then B tends according to the fifth production, that is B tends A, B, and finally this B is to be expand with the epsilon, and now I got that AB, right? So that here for the same string deriving, I got the two past trees, and the structure of these two past trees are not equivalent, so that the G2 grammar is also a ambiguous grammar, right? So that I can say that the G1 and G2 are the ambiguous grammar, so that the option number C is a right one. Let L1 be a recursive language. Let L2 and L3 be languages that are recursively enumerable but not recursive. Which of the following statement is not necessary to? Okay, he has given the languages such as that L1 is a recursive language and L2 is a recursive enumerable language and L3 is also a recursive enumerable languages. And we have to find out that which one is a false statement. That is, he is asking about that the following statement is not necessary to, which one is a false statement. And see the first option, that is L2 minus L1 is a recursively enumerable. Okay, so for this one we have to write that what is L2. L2 is recursive enumerable minus, and what is L1? L1 is a recursive language, and minus for this one we can write it as recursive languages intersection recursive complement. Okay, so here the recursive enumerable languages, here the recursive languages are closed under the complement, so that the complement of recursive languages is a recursive itself, and while you perform the intersection with the recursive enumerable languages with the recursive language, it is the answer is the recursive enumerable. So that option number A is a true statement. And if you take the second option, that is L1 minus L3, then what is an L1? L1 is a recursive language minus L3. What's an L3? L3 is a recursive enumerable languages. Then we can write it as recursive minus, for this minus we can write it as recursive intersection recursive enumerable complement. Okay, and then recursive languages intersection recursive enumerable complement. The complement of a recursive enumerable language is not be closed. Recursive enumerable languages are not closed under the complement operation, so that this option is a invalid one. It is not a true. So that here option number B is a right answer. Now if you observe that the third one, that is L3 intersection L1. What is an L3? L3 is a recursive enumerable intersection. What's L1? L1 is a recursive languages. Okay, so if you perform that recursive enumerable languages intersection with the recursive, then the answer is the recursive enumerable. Both are closed under the intersection operation. In the same way, the L2 intersection L1. What's an L2? L2 is a recursive enumerable intersection. L1 is a recursive, and both these languages are closed under the intersection. So the answer is the recursive enumerable. So that A, C, D are the true statement. Only the option number B is a false statement, and we want the false statement, so that option number B is a right answer. See the next question, the question number 29. Given the language L equal to AB, AA, BAA, which of the following strings is or in L enclosure? We have to find that what are the valid strings from the given language L. The language contains the three symbols. One is that AB, next one is AA, and third one is BAA. And see the first option, AB. AB is a valid one according to the first symbol of a language, and next one is AA is a valid according to the second symbol of L, and AA is also valid. Next one, BAA is a valid according to the third string of a L, and AB is also valid according to the first string in a L, and AA is also valid according to the second symbol of L. So that here option A is a right one. And second one, AA, yes, it is matches with the first one, second one, and again that AA is matches with the second one, and next one is BA is matches with the third string of L, next one AA is matches with the second string of L, and AB is also matches with the first symbol of the L. So that here option 2 is also a right one. And next one, option statement number 3, BAA, yes, it is valid according to the third symbol of L. Next one, AA, yes, it is matches with the second symbol of L, and next one, that is AB is a valid statement. It is matches with the first string of L. And next one, that is AA, yes, is matches with the second symbol of L. And next one, AAB. So AAB is not matches because of here AA is matches with the second symbol, but B is left here, so that B is not the answer, so that B is not the right one. Now see the next option, that is BAA, yes, it is matches with the third symbol. Next one, AA is matches with the second symbol of L. Next one, AB is matches with the first symbol of L, and AA is matches with the second symbol of L, so that 1, 2 and 4 are the right options. So option number C is a right answer for this question. And next one, he has given that grammar. From this grammar we have to find out that what is the first and follows of the grammars. Okay, so see that this grammar, first we have calculated that what is the first of non-terminals, and then we can calculate what are the follows of the non-terminals. Okay, first to see that how can calculate the first of A here, right? So the first of first we will take this root symbol, that is E, first of E. So what is the first of E? So while calculating first of E or the first of non-terminals, first of E, what's first of E here? First of E is a T. T is a non-terminal, so it means that first of E is the first of T. And what is the first of T? First of T is first of T is a F. F is a non-terminal, so that first of T is first of F. And what is the first of F? First of F is, that is opening bracket and then ID, so that we can write it as first of E is opening bracket comma ID. Next we can calculate that what is the first of E dash. What is the first of E dash? First of E dash is a E dash here, so that first of E dash is plus and epsilon. We can write plus comma epsilon. Next, what is the first of T, right? So what is the first of T? First of T is F. F is non-terminal, so that first of T is becomes the first of F. What is the first of F? The first of F is opening bracket comma ID, so that it is opening bracket comma ID. Next, what is the first of T dash? What is the first of T dash here? Here we have a T dash. The first of T dash is the star symbol and epsilon, so that you can also write the epsilon. Next, first of F. What is the first of F? The first of F is opening bracket comma ID. Okay. Now let us see the calculation of the follow. So what is the follow of E? So follow of E means we have to look at the right hand side, where is the E. So in this production rules, E is at the last production rule, that is after the E follows the opening bracket, so that you can write that, closing bracket. And E is a start symbol of this grammar. E is a start symbol of this grammar, so that you can be said that we can add the dollar symbol in the follow of the start symbol of a grammar. Okay. Next, follow of E dash. So follow of E dash, where is the E dash in the right hand side? Here we have a E dash, and here also we have an E dash. So E dash follows. So after the E dash we doesn't have any symbol here, so at that time follow of E dash is the follow of E. So what is the follow of E? Follow of E is closing bracket and the dollar. Okay. And second production rule also we have a E dash, and E dash follows nothing here, so that follow of E dash is the follow of E dash. So that is follow of E dash is closing bracket comma dollar. Okay. Next, we can calculate that what is the follow of T. What is the follow of T? We have to find out that where is the T in the production rule at the right hand side. In the right hand side we have a T here, and as well as we have a T here. Okay. So that first take the this production rule, that is after the T follows, that is a E dash, so that we have to find out E dash is a terminal, so that we have to find out that what is the first of E dash. What is the first of E dash? We know that is a plus comma epsilon, that is plus comma epsilon. Here in this follows calculations we never write the epsilon symbols, so that when the E dash is epsilon, so that when the E dash becomes epsilon, at that time the follow of T is becomes that follow of E. what is the follow of E? That is the closing bracket comma dollar, closing bracket comma dollar. Okay. So it is a follow of T. Next, find out that what is that follow of T dash. So we have to find out the where is the T dash on the right hand side of this production rule. So T dash here as well as the T dash here. Okay. Firstly, this production rule, T dash, after the T dash we doesn't have any symbol at the time, the follow of T dash becomes that follow of T. So what is the follow of T? Follow of T is plus comma closing bracket comma dollar. Now take this last production rule, that is T dash 10 star ft dash epsilon. So after this T dash we doesn't have any symbol at the time, the follow of T dash becomes the follow of T dash. What is the follow of T dash? That is a plus comma closing bracket comma dollar. Okay. Next, calculate that what is that follow of F. What is the follow of F? For this one we have to see that right hand side of this production rule, where is the F, and here we have F and here also we have an F. So now see this production rule, after the F we have a T dash. So T dash is a terminal, is a non-terminal, so that we have to calculate that what is the first of T dash. What is the first of T dash here? That is called as star comma epsilon. We never write the epsilon in the follows, so that remove this epsilon, that is star, we can write the star only. Okay. So when it was the epsilon, at the time, follow of F is becomes the follow of T. What is the follow of T? That is plus comma closing bracket comma dollar sign. Okay. So now see this production rule, and here also we have F. After the F we have a T dash. What is the T dash? Is a non-terminal. At the time we have to calculate that what is the first of T dash. What is the first of T dash here? That is a star comma epsilon. Already we have written the star. When it is an epsilon, when the T dash becomes that epsilon, at the time follow of F is becomes the follow of T dash. What is the follow of T dash? Plus comma closing bracket. Plus comma closing bracket is already written here. Okay. So this is the first and follows calculation. Now according to the options, option A, first of E is opening bracket comma ID, yes it is true, and first of E dash, that is star comma epsilon, first of E dash is plus comma epsilon, so that it is a wrong one. So that option A is a wrong one. Now see the option number B, first of E is opening bracket comma ID, yes it is true, and see the first of E dash, what is the first of E dash? Plus comma epsilon, yes it is also be the true, and first of F, the first of F is given here opening bracket comma ID, and here the first of F is also opening bracket comma ID, so that is also true, and follow of F, what is the follow of F? Plus comma closing bracket comma dollar. Now see that follow of F, what is the follow of F? It contains the star also, so that here follow of F is a wrong, so that option number B is a false statement. In the same way, first of E is ID comma opening bracket, yes it is true, and first of E dash is plus comma epsilon, yes it is also true, and follow of E is, that is closing bracket comma dollar, it is also true, and what is the follow of T dash? The follow of T dash is that plus comma closing bracket comma dollar, but here the plus is not be there, so that it is a false one. So that option number C is also not the answer. And option number D, first of E is, what is the first of E? That is ID comma opening bracket, yes it is true, and first of E dash is plus comma epsilon, it is also true, and follow of E is, that is closing bracket comma dollar, and follow of T is plus comma closing bracket comma dollar, yes it is also be the true. So that option D is a right statement in this question. Now see the next question, the question number 31. It is saying about that the number of states in the minimal DFA corresponding to the regular expression. Okay, he has given that regular expressions, that is that 0 plus 1 whole clean star, and then follows the 1 0. Okay, so for this one, first we have to be draw the DFA diagram, and then we have to find out that what are the final states and non-final states in this DFA diagram. Okay, so for this one, if observed here, it can generate the strings which may have the any number of zeros and ones, but must be ends with the 1 0. Okay, so that for this one we can draw the DFA like that. Q0, okay, 1 0 is a compulsory, it is everything must be ends with the 1 0. So that Q0 state, from the Q0 state is a 1 transition on 1 we reach the next state, that is a Q1, and from the Q1 we reach to the Q2 state by on 0 transition, and Q2 is a final state. It means that we must get the string which may have at least 1 0 ended with a 1 0, so that it is a one DFA for the 1 0 regular expression. Okay, and it is a DFA. DFA means so from the same state we doesn't have a more than 1 transitions on the same input symbol. It means that from the Q0 already there is a transition on 1, but again we not be able to get the transitions on the same input symbol 1 from the same state Q0 because of it is an DFA, but it is allows in a NFA. Okay, so that is once we get the transition of the 1, and next we have to get the transitions with the 0 input symbol, that is Q0. Okay, Q0 from Q0 and 0 input symbol to the same state Q0. Okay, after that from the Q1 already we have a input transitions on the input symbol 0. Next we have to be write the transition from the Q1 on the input symbol 1. Okay, and from the Q2 we doesn't have any transition. Okay, so that here I am writing the transition from the Q2 to Q1 on the input symbol 1, and from Q2 to Q0 on the input symbol the 0. Okay, and this is a DFA for this regular expression 0 plus 1 whole clean star and 1 0, right? And from this one, from this DFA we have to find out that what are the minimal number of states we can get from this DFA. Okay, so for this one first we have to be divide these states into the 2 sets. One set is called as a non-final set, and next one is a final set. Okay, so in this non-finals we can contains the states which are not final, that is the Q0 and Q1 are the non-final states, and the Q2 is a final state, right? And from this final state, from this state, if you observe here in this set we have a 2 elements, and in this state we have only 1 element. When you have a more than 1 element in a set, then you have to be consider that set and apply the transitions on these elements of these states. So in this set we have 2 elements. First I taken that Q0 and then Q1, and from this set, from the states we have to be apply the transitions on the input symbol. In this DFA the input symbols are 0 and 1 only, so that first I am applying the 0 transition on Q0 and then 0 transitions on Q1. So on Q0, on the 0 transitions we are reaching to the Q0 state, and at the Q1 state at 0 transition we are reaching to the Q2 state. Okay, if you observe that here the Q0 is a part of this same state and Q2 is the part of the second set, so that when you get the different sets, okay, when you get the different sets at that time, it means that Q0 Q1 are not be the friends, they are not be the friends, they have to be divided, they are not be have the same characteristics. Q0 Q1 both doesn't have the same characteristics at that time. We have to be split this set into the 2 sets, that is one set contains the Q0 and second set contains the Q1 and the third set contains the Q2. Okay, so here we get each and every set contains only 1 element, so that when you get only 1 element, then there is no need to apply the transitions on the input symbols. So that here how many states are there? There are 3 states, 1 2 3. So that here the answer for this question is option number B. Now see the next question, the question number 33. The grammar S tends A S A, S tends B S and S tends C. So if you observe that in this grammar, we have to find out that whether the grammar is LL of 1 or LR of 0, or both the LL of 1 or and LR of 0. So for this one, to find whether the grammar is LL of 1 or not, we have to be calculate the first of this right hand side, first of ASA, and then first of BS, and then first of C. And if you get any common element in this first calculation, then you can be said that the given grammar is not be an LL of 1. Okay. For example, here the first of ASA is equivalent to the, what is the first of A here, what is first element, this is a terminal, so that here you can write the A. And next one, first of BS, what is the first of BS, it is a B only, the first element. And the first of C, so it is a terminal, and you get the C only. Okay, so here in this 3 A, B, C, here there is no common element. When there is no common element, then you can be said that it is a LL of 1 grammar. So when the grammar is LL of 1, you can easily say that the grammar is LR of 1, is a LR of 1. Okay, so that you can be said that the option number A is the right one. It is a LL of 1 as well as it is a LR of 1. Okay, so this is the table. Actually, this is a table for the question number, I think it may be of a 26 and so on. That is the closed under properties. So each and every language, we have a different types of language here. One is a regular language, context free language, DCFL language, CSL, recursive language, recursive enumerable language. To find the closure properties, we can use this table. Okay, if you by heart this table, you can easily answer the question. That is the questions like that. That is a L1 minus L2 is a recursive enumerable or the recursive language, or you can write it as L1 intersection L2 and L1 union L2. So for finding the closure operations, whether the language is closed under the union or the intersection or the complement, difference, reverse, regular intersection, concatenation, homomorphism, inverse homomorphism, we have to write this table. Okay, if you understood this table, you can easily answer the question. If a language is regular, then you can be said that it is a DCFL, CFL, CSL, recursive and recursive enumerable language. If the language is a recursive language, then it may be of a recursive enumerable, but it is not be a CSL, CFL and so on. Okay. Now see the next question, the question number 34. It is the question is the match the following. We have to match the elements of list 1 with the list 2 elements, and see that lexical analysis. The lexical analysis means it is depends on the finite automata. It is understood by the finite automata machine. We have two types of finite automatas. One is NFA, next one is a DFA. So that lexical analysis is matches with the DFA. And the parsing is matches with the production trees, so that we can draw we can generate the parse trees here. And the register allocation is the graph coloring problem, and expression evaluation is a post data traversal. Okay, so that the option number D is a right answer. Next one, the question number 35. Consider the grammar. He has given the grammar, and in this grammar we have to be find out that for this statement, that is n plus n into n, the handles in the right sentential form of the reduction. So we have to find out that what are the handles for this given production rules. Okay, we have the first production rule, that is E tends E plus n, E tends E star n, E tends n. We have to find out that what are the handles here. Okay, for this one, draw the table, so which contains that right sentinel forms, right sentinel form. Okay, right sentinel form, and then we have that handles, and finally we have the production rule. Okay, now say that in this production, in this given string n plus n into n, here I am writing that the same string n plus n into n, and this n is to be reduced by using the third production rule, that is a E tends n. Okay, so this n is reduced by using the third production rule, that is a E tends n. Now this n is to be written as E, so that E plus n into n. And if you observe that this E plus n is to be reduced into the E by using the first production rule, that is E tends E plus n. So what is the string I am reducing here? E plus n into by using the product into E by using the production rule E tends E plus n, and finally I got the E here, E star n, and this E star n is to be reduced by using that third production rule, second production rule, E tends E star n, that is E star n is to be reduced by using the production rule E tends E star n. Now write the handles here. What are the handles? The handles are first n, after that E plus n, and after that E star n. So that the answer for this question is option number A. See the question number 36. Consider the following grammar: S tends AB, A tends A tends BAB, B tends BBA. Okay, and we have to find out that what are the strings it can be generated, and in the string how many number of S and how many number of B occurrences are there. Okay, so for this one you can either go with the derivation mechanism or you can go with the positive mechanism. So here I am following the positive mechanism, that is I am drawing the pos tree. So first take the first production in this grammar. What is the start symbol? S, so that I am taking that S tends AB, and this A is to be derived, is to be expand with the terminal A according to second production rule, and then B is expand with that B, and then A, and finally A is to be expanding with that B, A, B, and this B is to be expand with the B, and then A, and this A is to be expand with the A, and finally this B is to be expand again with B, A, and finally this A is to be expand with the A. Now what are the string I got here? That is A, B, B, A, B, B, and then A. Okay, so write this string, that is A, B, B, A, B, A. Okay, so now I am drawing one more pos tree. S from using the S, that is S is expand with the AB, and this A is to be expand with the B, and this B is to be expand with that B, A, and this A is to be extend with A, and B is expand with the B, A, and this A with the A, and finally this one is B, A, and A is expand with the A. Now you get to the string, that is the B, A, B, A, B, and A, so that you can write it as here the B, A, double B, A, double B, and A. Now observe the options. Option number A, the length of every string produced by this grammar is even. So the length of every string, what is the length of this string here? The length of the string is that, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a 10, and here the 4, 6, 8, 10. It is a 10. So the even number. Okay. So the length of every string produced by this grammar is even. Yes, it is an even. So that here it is a true statement. And no string produced by this grammar has 3 consecutive years. So here observe that no string produced by this grammar has 3 consecutive years. 3 consecutive years undakudu. Okay, so what are 3 consecutive years? Is there any 3 consecutive years here? So no 3 consecutive years. Yes, no 3 consecutive years. So that here there is no string which contains the 3 consecutive years. So that here the option number B is also the true one. And the length of the substring produced by the B is always odd. So length of the substring produced by B. So by using the B production rule, what are the strings we have produced here? That is a BBA, and it is also the BBA, right? So that this B is to be generate the string BBA, which contains only the 3. 3 is an odd number, and this bit generate the string BBA. It is also the 3. So that here the B is also generates the string BBA. It is a 3. So that 3 is an odd number. So that option number C is also the true one. No string produced by this grammar has 4 consecutive B's. So is there any 4 B's in the given strings here? 4 consecutive B's. So where are the 4 consecutive b's here? Here there are the 4 consecutive b's. Here the 4 consecutive b's are there, and here dono consecutive b's are there. So that you can say that you can generate the strings which have the 4 consecutive b's or not 4 consecutive b's. So that here this option is the false statement. So that we request that which one is a false statement. So that the option number D is our answer. Here option number D is a right answer. Now see the next question, the question number 41. Relational calculus is a non-procedural language, whereas the relational algebra is a procedural language. Now see the next question, the question number 42. Which of the following is not a reason NoSQL has become a popular solution? And for this one, the option number C is the right answer. That is the improved ability to keep data consistent. And the next question, the question number 43, is saying that the language used in application programs to request data from DBMS is referred to as. So it means that, so what are the that is the request means that is a select operation. The select is comes under the DML, so that the DML is a right answer. By using the DDL, actually in DML we can get the select, insert, update and delete operations, and under the DTLs we can get the commands such as the create, alter, drop, truncate and rename operation. Here the answer is the DML, that is stands for data manipulation language. Next to see the question number 44. Each modification done in database transactions are first recorded into the, so before you perform any operation on the database, that operations not directly recorded on the database, first it write into the log files, and from the log files it can be updated into the database. So that here the answer for this question is that option number D, that is the log files. See the next question, the question number 45. R of w comma x comma y comma z is a relation which of the following does not have a lossless joint dependency. He has given the 4 options, and we have to find out that which one is a lossy joint dependency. Okay, so for this one, to find out that whether it is a lossy or lossless, we have a 3 types of condition. The first condition is that the decomposed relations, if you perform the union on the decomposed relations, is equivalent to the number of attributes in a R, that is R1 attributes union and R2 attribute union. It is a union operation. Okay, union is equivalent to the R1. It means that number of attributes of R1 plus the attributes of R2 is equivalent to the R1. It is the first condition. And second condition is that R1 intersection R2 is not be null, is not equal to the null. And third condition is that R1 intersection R2 is a one of the attribute, and that attribute is a key attribute or the prime attribute in any one of the decomposed relation, key or prime attribute in any one of the decomposed relation. Okay, so now see that first option number here, that is the w tends x and then x tends yz. So in this one, apply the first condition, that is R1 union R2 is equivalent to R. So what are the attributes in this R1? That is wx, and this R2 we have that x, y, z, and so that you can get the attributes, that is w, x, y, z, and these are the 4 attributes are present in a R, so that the first condition is true. And see the next condition, that is R1 intersection R2. So if you perform that R1 intersection R2, so R1 contains wx and R2 contains x, y, z. Here the common attribute is that x, so that it have an x. It is not equivalent to 0. It have at least one attribute. So that the second condition is also be the true. And so the next condition, that is R1 intersection R2, which get an attribute as a result. That attribute is either a key or prime attribute in any one of the relation in any one of the decomposed relation. Okay, so see that x is a prime attribute or not. So for this one, refer the functional dependencies given in the option number A, that is w tends x and x tends yz. See that x is determining that yz, so that you can say that x is a prime attribute or the key attribute. So that option number A is a lossless joint decomposition. Okay, so now see that next option number B, that is W tends X and then X tends Y and then Y tends Z, and apply the first condition, that is R1 union R2 is equivalent to R. Okay, so what is that R1 union R2 union R3? Here the three relations are there, so that the R1 contains Wx and R2 contains Xy and R3 contains Yz, and it is equivalent to that four attributes of relation R, that is X comma Y comma Z comma W. So that here the first condition is true. And what is second condition? That is the intersection of these relations, that is first take that R1 intersection R2. What is the R1 intersection R2? So it is not equivalent, that is it is not equivalent to 0, right? It is not equivalent to null. So here R1 contains Wx and R2 contains Xy. Here the common element is that X, so that it is a X. And if you perform the intersection with the R2 intersection R3, in this R2 and R3 Y is a common attribute, so that it is also not equivalent to the null value. And next one is that if you perform that intersection with the R1 R2, here you get that X. Now see that X is a prime attribute here. Yes, S is a prime attribute in a relation R2. Okay, as well as if you observe that if you perform that intersection operation with R2 and R3, the answer is Y, and Y is a prime attribute. Yes, Y is a prime attribute in a relation, decomposed relation R3, so that the B is a lossless joint decomposition. We have to find out that which is not a lossless joint decomposition. Okay, so now see that option number C, that is Wx tends Y and then Y tends Wz, and in this one if you perform the first condition, that is R1 union R2, is it equivalent to the R? So see that R1 contains the attributes, that is W Xy, and R2 contains Y Wz is equivalent to the R of W comma X comma Y comma Z. Okay, so that the first condition is true. Now check the second condition, that is R1 intersection R2, right? So if you perform that R1 intersection with R2, is it equivalent to 0? No, because of R1 and R2, say that we have a two elements are in common, that is a Y, next one is W, that is Wy, so that it is not equivalent to the null. Now what is third condition? So R1 intersection R2, we get an attribute, that attribute must be a prime attribute in any one of the decomposed relation. Here we have a Wy, so here the Wy is not the prime attribute here, only the Y is a prime attribute. Because of by using the Y, we are finding the values of Wz, but with the help of Wy, we are not be able to finding any values here. Okay, so that this one is also satisfies the BCNF. Okay, so because of Y is a prime attribute and this Y is determining with the help of W. Okay, so it means that it is also not in BCNF, as well as it is not be in a lossless, so that it is a lossy decomposition. So the option number C is a lossy decomposition. It is a lossy decomposition. Okay, so next one is W tends XYZ. Yes, it is a only one relation, so here it is a lossless, so that here the option C is a lossy decomposition. Option number C is a right answer. Next, see that question number 46. It is saying that data transformation means. So data transformation means is the process to change data from a detailed level to a summary level. So that option number A is a right answer. And see the next question. The question number 47. The main use of kernel trick is implicitly mapping the inputs into high dimensional feature space. See the next question, the question number 48. Valid XML document means. The valid XML document which has DTD associated with it and complies with that DTD. So here DTD stands for document type definition. So here option number C is a right answer. And next question 49. Hadoop was named after a toy. Okay, and the next one ETL. So ETL stands for extract, transform and load. So that here option number B is a right answer.